Alright, you're recording. Present mode. What? Can you stop popping up? 5, 4, 3, 2. Hey folks, in this video we're going to go over how we can do pretty quick problems or problems with our ball launcher. So as you're going through the ball launcher activity, you can peep this and get some clues as to what to do. No subtitles. Let's get started. So we got a ball, it's launched. I don't know what the exact speed of our ball launchers is, or what you'll be getting, but ours is going to go 12 meters per second to the right at 50 degrees above the horizontal. From a height of 0.25 meters. So we want to figure out what is the horizontal displacement of the ball. The other piece of information that we're going to know is that gravity is going to cause downward acceleration at 9.8 meters per second. Cool. So let's make a diagram. But before we make a diagram, let's start pulling out our data. And so we're going to want to break everything into components because that makes life really easy. So we'll start with our initial velocity, and we're going to bust that into components. So we'll come up with the horizontal component and the vertical components using our trigonometry functions. We're also going to just pull out that our vertical displacement is down if we're starting at a height of 0.25 meters. Well, at the end of our launch, we're going to land on the floor, so we'll be moving a total of 0.25 meters down. And we have no horizontal acceleration as we move side to side. That velocity is not going to change. It's not affected by anything. The only acceleration we have is our up-down acceleration from gravity. And we may sometimes be using this as, instead of 9.8 meters per second squared down, negative 9.8 meters per second squared up. Cool. So we can start putting together a little picture for this. We've got our initial velocity here, ball up on top of, well, at a height. I didn't show the launcher here, and our angle. And so we're interested in our horizontal displacement. Let's just make my face go away. So we're only interested in our horizontal displacement at this point. And we know our vertical displacement, and we already came up with our vectors for velocity as vertical and horizontal. So we can use this fun equation, our displacement, relative to initial velocity and acceleration and time equation, and we can plug in our values for that. And since we have no horizontal acceleration, really our horizontal displacement is just going to be equal to the time the ball is in the air multiplied by its horizontal velocity. But what is the time in the air equal to? How can we go about figuring that out? Well, we're going to have to do some other steps to get there. And so one of the first things we're going to do is figure out what our balls, oh, that all appeared at once, what our balls vertical velocity is at the end of this, because if we know the velocity at the beginning, its initial vertical velocity, which we do, if we're able to find its final vertical velocity, we can figure out, yeah, this final velocity. And if we know its initial velocity and final velocity and its acceleration in that area, then we're able to figure out how long the ball will be in the air. So we can use this fun equation to get our final vertical velocity, and really it's just a matter of plugging all of our stuff in. The only thing we have to be concerned about is making sure that all of our directions agree. So here we've got up, down, and down. Well, I'm going to convert those downs into up, and to make that change, I'm just going to slap a negative sign on them. Great, and we can map this. We get our final velocity in the vertical vector. Our final vertical velocity is 9.5 meters per second down. Groovy. So now with that additional piece of information, we are really quickly able to figure out what our time is. So our final velocity is equal to our initial velocity plus acceleration times time, and we can rearrange that so the change in velocity, or the final minus the initial, divided by acceleration is equal to time. And we can just plug stuff in. The only thing we got to be concerned about here is that we make all of our directions agree. So I swap this up to a down by putting a negative sign on it. That minus, a negative minus becomes addition, and really quickly we can solve for time. And then, like we said before, time, we are able now to plug that into this equation for displacement. We know that horizontal acceleration is equal to 0, so all we care about is horizontal velocity, time, and those will lead us to our horizontal displacement. 15 meters to the right. Awesome. So if we you can see breaking stuff up into components makes our life real easy for doing these calculations that are otherwise weird, where stuff's flying off at angles. I don't know why I was doing hand signals there. You can't see what I'm doing. Look, you can look. Just get a look. Vectors. Oh my gosh. Vectors. Anyway, thanks for watching. Ta-ta.